In Level 3, you'll be solving compound inequalities that may or may not require flipping the inequality sign. Whenever you have an OR inequality, you know right away that it's going to be an inequality that has arrows going outwards in two opposite directions. So we can predict already that this inequality is going to look something like that. And whenever you have an inequality where the expression is in between two other numbers, that's going to be a situation where x is in the middle of two numbers and it's shaded in between. So just keep that in mind, that that's what our inequalities are going to look like in the end. You can tell just by looking at them before you solve anything what it should look like when you're done. But back to solving them, if we look at this first example, whenever you have an OR inequality, you have to solve the two equations separately. So I'm just going to put a line down the middle and treat this like two separate problems. So if I start with this left-hand inequality, first I would distribute. I solve it just like an equation, and I get 2x minus 6 is greater than or equal to 4. Next I would add 6 to both sides, and we get 2x is greater than or equal to 10. Divide both sides by 2, and x is greater than or equal to 5. Now I go to the right side and solve that inequality. So I add 2 to both sides, and I get x over 3 is less than positive 1. And since x is being divided by 3, to cancel that 3 out, I'm going to multiply both sides by 3. The 3's cancel, and I get x is less than 3. So now my answer will be, I start with my lower number, so I'm going to write this one first. X is less than 3, or x is greater than or equal to 5. And now I graph that on the number line. So x is less than 3. I do an open dot at 3 and shade to the left where the numbers are less. And x is greater than or equal to 5 will be a closed dot because of the line underneath the inequality sign, and we shade where the numbers are greater to the right. Now in this next example of the other type of compound inequality, the AND type, where x is in between two numbers, instead of doing two separate equations like we just did, now it's just one big equation that has three parts to it. So my goal is to get x by itself, and whatever I do to the middle to get x by itself, I also do to the left side and to the right side. So the first thing I would do to solve for x is multiply both sides by 3. And I actually multiply all three parts by 3. So in the middle, the 3's cancel. On the left side, we get negative 6. I bring down my inequality sign. I bring down that was negative 2x minus 4. I bring down my other inequality sign, and 0 times 3 is 0. Next, to get x by itself, I would add 4. And I do it on the left, the right, and the middle. The 4's cancel in the middle, and on the left side we get negative 2, which is less than or equal to negative 2x, which is less than 4. Now I divide by negative 2 to get x by itself. And since I'm dividing by a negative, I have to remember to flip the signs. So whenever you divide by a negative, like we just did right here, the signs flip. So they're now going to face this way. So on the left side, negative 2 divided by negative 2 is positive 1. My negative 2's cancel, and I get x in the middle. And 4 divided by negative 2 is negative 2. Now, if you want to, you can rewrite your inequality with the numbers in order, with the lowest number first. So I would write negative 2, and then I take this inequality and flip it, because I'm writing it the opposite way, and then I have x, and then I take this inequality and flip it and put 1 here. Now, if you had left this as your answer, that would have been okay too. but I think writing the numbers in order makes a little more sense than the number line. Now when we go to graph it, this is saying that x is greater than -2, so I have an open dot at -2 and I'm shading this way, and x is less than or equal to 1, so it's a closed dot at 1, and it's just shaded in the middle. Okay, our last example is another example of an OR inequality. So again, I think of it as two different equations. I do the left side first. I subtract 6 from both sides. We get -1/2 x is less than -2. And then to get rid of that -1/2, I'm going to multiply both sides by the reciprocal of -1/2, which is what you get when you flip it. So I'm going to multiply by -2/1. And I'm going to multiply the other side by -2/1 also. And that's the same as just -2. The negative times negative cancels, and we get +1x on this side, just x. And we have to flip the sign because we just multiplied both sides by a negative number. So again, if you multiply or divide both sides of the inequality by a negative, you flip the sign. So it was a less than, now it's going to be a greater than. And then on the right side of the equation, -2 times -2 is +4. So we get x is greater than +4. And then we do the next inequality. We distribute, we get -2x minus 2 is greater than or equal to 10. Add 2 to both sides. -2x is greater than or equal to 12. Divide both sides by -2, and again I'm dividing both sides by a negative, so I have to flip my inequality sign. And we get just x on the left side, and 12 divided by -2 is -6. So my final inequality, if I write my lower part, my part with the lower number first, would be x is less than or equal to -6, or x is greater than 4. And now we put that on the number line. It's a closed circle at -6. We shade where the numbers are less. And x is greater than 4 would be an open circle at 4, shaded to the right.